Hello, this is Moresh, and today we'll continue to investigate pattern recognition further. And today's problem is a little bit more challenging than our previous set of questions, but we'll come up with some strategies to solve challenging problems. Fill in each blank with digits from 1 to 9. Okay, so these are the blanks, and we have to fill them with digits from 1 to 9. Each digit can only be used once, so you can't repeat like 1 here and then 1 here, or 3 here, 3 again. No, we can't do that. They can only be used once, and the number on the left hand side of the arrow, which means the number over here, it's not 0, it's like the number on the left side of the arrow, is added to 12 to get the number on the other side. So this plus 12 equal to this plus 12 equal to this plus 12 equal to this, and so on. And our task is to fill all these blanks in a manner which meets these requirements. Now this looks like a challenging problem, but I'm going to tell you a strategy which will allow you to solve most challenging problems. And the way to solve any difficult problem is to first break it into smaller problems and then solve the easiest of the small problems first. Okay, so now effectively there are 5 problems over here: 1, 2, 3, 4, and 5. We broke down our big problem into 5 smaller problems. Now let's start by finding out which one of these problems is the easiest one. Now this one, okay, this one looks to be the easiest one. Why? Because each one of them requires us to have some sort of a multiple step thing going on, whereas this one is quite straightforward. Something plus 12, it says that something is x, plus 12 is 24. We know that 12 plus 12 is 24, okay, which means if we can just clear this up, quickly clear this up. Then we can start by filling up 12 plus 12 is 24. We'll just write down the numbers which we have as an option. So it's 1, 2, 3, 4, 5, 6, 7, 8, and 9. And we have so far used 1 and 2. So for the remaining boxes, this we can only use 3, 4, 5, 6, 7, 8, and 9. Okay? That narrows down the problem a little bit. So we have already completed 1 out of 5 problems, and now 4 are remaining. Okay? Now let's see what is the next easiest problem. The next easiest problem is this one. Why? Because there is only one thing to solve for, whereas in each of the other ones there are 2 things to solve for. Okay? Now let's see. Something plus 12 is equal to 41. Now let's call it x. Now this becomes x is hence 41 minus 12, and the answer is 19. Sorry, the answer is 29. So, sorry, my bad. So the answer is 29. Okay. So now we have completed 2 out of 5 problems, which means that out of our remaining digits, 9 is gone. Right, 9 over here, and we'll shade it up. All right. Now, there are 3 problems remaining. Okay. And let's see which one of these are easy. I like this one more, and I'll explain you why. Because it gives us 1 box equals box 0. Now this part of the problem narrows down our options a little bit, because that's something which ends with 0. See this? This ends with 0. Now that kind of constraints what can go into this box. Now let's see. Our options are, for this box it can be 3, 4, 5, 6, 7, 8 and 9. Now realistically, can it be 8? It can't be, because assuming this was a 2-digit number, the biggest 2-digit number it can be over here is 19. 19 plus 12 cannot reach 80. Realistically, it cannot reach 70 as well. It cannot reach 60, it cannot reach 50, it cannot reach 40. It could reach 30, right? And so 19 plus 12 theoretically is greater than 30, but something which is a 2-digit number which begins with 1 can reach 30. Okay. Theoretically, it can be 20 or it can be 10. So it can be no more than 30. Okay. Now because it starts with 1, it's a 2-digit number, which means it can be 11, 12, 13, so on and so forth, based upon whatever numbers we have remaining over here. Okay. Which means 10 is out of the option, because 10 is actually smaller than 11. So 11 plus 12 cannot be 10. Okay. So this digit over here cannot be 10, and we have also used up it already. So realistically, the only options over here are either 2. It can be either 2 or it can be 3. Okay. Now let's clean this up a bit so that we have our board ready again. This is 3, this is 4, this is 5, this is 6, this is 7. So 1 box 0. This is the problem from here. So this can be either 2 or this can be 3. Now 1 box plus 12 equal to, let's take 2 as the option. Okay. Something plus 12 is equal to 20, which means the answer for this one has to be 8. 8 plus 12 equal to 20. However, this is a 2-digit number. This one is a 2-digit number, and 8 is not a 2-digit number. So it cannot be 2. So after eliminating all the possible options, whatever remains has to be the correct answer. If you have read Sherlock Holmes, you will see that he keeps on repeating all this again and again. He goes through all the possibilities, eliminates that, and then the remaining possibility is always the correct answer. Oftentimes, however, illogical it may seem. In this case, it is actually logical, but I'm just paraphrasing Sherlock over here. So the answer over here, let's verify. Okay. We are saying that it is going to be 3, 0, 1 box, and the box over here is 30, and 1 box plus 12 equals 30. So what plus 12 is 30. X is bound to be 30 minus 12, which is equal to 18. So the answer is 18. So in this box, we have 8, and in this box, we have 3, which means we have knocked down 2 more from our thing. And from our set of problems, we have completed 3 out of 5. So how many are remaining now? 2 are remaining. Let's delete this. All right. We will clean this up a bit. So the only remaining problems are this one and this one. Okay? Now let's see. Both of these are equally challenging because they have effectively 2 parameters which we have to find out. And let's see. Now, how do we go about solving these problems? This one looks a little bit easier because it has 2 boxes which we need to find out, but one of them is a single digit, whereas both of these are 2 digits. So this looks relatively easier. Let's see. Now, box plus 12 equal to 1 box. Okay. Let's see. How do we go about it? So let's say this is A and this is B. Let's clean this up a bit. A plus 12 equal to, now this 1 is in the tens place, so it's actually 10 plus B. Okay. Now, what we'll do is we'll move this 12 on this side and we'll move this B on this side, which means B minus A is equal to 2. I jumped a few steps over here, but let's actually go back, okay, so that I can explain how I came up with this. So what we are doing over here is, I'll erase this. I'll go step by step. We'll move this A over here. If we subtract A from both sides, it becomes 10 plus B minus A equals 12. And if we subtract 2 from both sides, or 10 from both sides, it becomes this. So which means B minus A equals 2. Okay? Which means the difference between these two is 2. Let's clean up our board. Always keep a clean board. Erase. All right. So we have 4 options, 4, 5, 6, 7. And the difference between these two has to be 2. So effectively we have 2 pairs over here, 4 and 6 and 5 and 7. So either it's going to be 4 and 6 or it's going to be 5 and 7. So it's going to be 4 over here and 6 over here, which actually works. 4 plus 12 equals 16. Is this correct? So 4 and 6 can work. But let's see if 5 and 7 work. 5 plus 12 equals 17. Both of them work. What to do? We can't actually solve this one with this much information alone. Okay? So we need to do this in combination with the other problem. Okay? Now, let's see 4 box equals 5 box. Let's say we used 4 and 6 over here. We used 4 over here and 6 over here, which means the only ones remaining are 5 and 7 over here. Let's put a 5 over here and let's put a 7 over here. Is 54 plus 12 equal to 57? No. Our maths is not that bad. 54 plus 12 is actually 66, not 57. Which means 5 and 7 are not the correct answer for this. Let's see if we can clean this up, and clean this up. Clean this up. Let's see if now 5 and 7 work over here, but 4 and 6 also work over here. But 5 and 7 don't work over here. Yeah. So let's see if 4 and 6 work over here. 44 plus 12 is indeed 56, which means the correct answer over here is 4 and 6. And the only one which is remaining over here hence becomes, what is the correct answer? It's 5 and 7. If we went by pure mathematical solving and using equations, it is actually doable as well. But this uses a process of elimination and inference rather than going the typical mathematical steps which we follow. Sometimes it is easier to solve problems by looking at what are all the possible options rather than actually going for it and solving across an infinite set of possibilities. If we just limit ourselves to the constraints which are there and see, okay, does this work, does this work, does this work, it can actually allow you to cut short a number of steps along the way and solve things in a much faster and efficient way. So remember, if you face a challenging problem, break down the problem into smaller sets of problems, solve the easiest problem first, and always look what are the options available and try to see if any of those options work rather than necessarily solving for every single possibility. Remember that and you should be good. Till next time, this is Moresh. Bye-bye.